Good afternoon, one and all. We have to be start the new chapter, that is field effect transistor, right? See, we have already seen the transistor. There is the shortest difference between transistor and field effect transistor. We know that transistor is nothing but a BJT. BJT indicate that bipolar junction transistor. See, field effect transistor indicate that the transistor which should have another configuration with respect to your BJT. BJT indicate that bipolar junction transistor. We know that there are basically two type of the BJT. BJT indicate that bipolar junction transistor, NPN and PNP transistor. Means normal transistor is called as bipolar junction transistor. There are two types, NPN and PNP. Field effect transistor is also the type of the transistor, but it has some of the different characteristics. See, what are the different way of discussing the further lecture. See, transistor, it is called as normally transistor, it is called as current control devices. What it indicate that we have applied the input, we got the output. So we have applied the input as a base current and we got the output as a collector current. Means we have applied the base current, we have got the output at collector current. So your input base current control the output collector current. This is the case in case of your BJT, but in case of field effect transistor, basically it is a transistor, but the whatever the working of this transistor are different, right? See, in case of field effect transistor, we have applied the voltage. See, in case of transistor, there are three type of the terminal with respect to BJT. One is your emitter, other is base, and third is collector. But field effect transistor have the three other terminals. That is a gate, drain, and source, which is same as like as your collector, base, emitter, as like as your transistor, but some of the different things. See, we know that in case of your transistor, applied current means input current, that is base current control the collector current. But in case of field effect transistor, applied the voltage. See, applied a voltage in between three terminal, gate, source, and drain. Applied a voltage between gate and source, which control the drain current. Right? Means to control the current, here voltage you have to be applied. See, when we have to be applied a input current which control the output current, that is not simple, but we have applying the voltage, input voltage, and which control the output voltage, it is a simple. And some of the advantages of field effect transistor, that's why in the application of industry we have more prefer the field effect transistor than that of your transistor. We have seen the first during the first chapter, that is a first, that is transistor related chapter, all the things with respect to the transistor. We have seen the field effect transistor. Basically, and draw the diagram of it, and then you have to see the difference between it. 1 minute. See, transistor, you know that I'm telling you, transistor normally BJT. 1 minute. This is a whiteboard. See, print. 1 minute. Net problem. See, we're discussing with respect to the BJT and JFET, right? See, BJT. BJT indicate that we know that bipolar junction transistor. Bipolar junction transistor. BJT indicate that bipolar junction transistor. 1 minute. Bipolar junction transistor. Basically, there are two types of transistor. One is NPN, other is PNP, right? These are the two type of transistor. NPN indicate that I am telling you why I'm telling you that the difference between transistor and APT. That's why I'm telling NPN. NPN transistor. This is your base. This is your collector. This is your emitter. This is for NPN type of transistor. PNP type of transistor. See, PNP. This is your base. This is your collector. This is your emitter. Okay, these are the three terminal of the particular transistor. NPN. This is your PNP. Only change is that NPN and the PNP, right? NPN have arrow towards the downward. What it indicate that your current flow from your base towards the emitter. See, this is N, P, N. P to the N current, P towards the N current flow. That's why arrow towards the down. इथं P असतं पहा. N, P, N. म्हणजे सांगतो परत एकदा पहा. इथं N असतं, इथं P असतं, इथं N असतं परत. म्हणजे N, P, N. P to the N current flow, त्यामुळे arrow खाली दाखवलेला आहे. इथं पहा. PNP. P to the N current flow, त्यामुळे वर दाखवलेला आहे. लक्षात येतं NPN PNP ट्रान्झिस्टर. हे झालं ट्रान्झिस्टर. म्हणजे actually diagram of the NPN and PNP type transistor. Now we have seen that field effect transistor. By its name that I'm telling, field effect. One of the effect which should be coming with respect to this type of the transistor means applied voltage, means applied a gate to source voltage which controls the drain current. That's why its name is field effect transistor. Transistor. See, field effect transistor. Only arrow is only change. See, this is called as gate. This is called as drain. This is called as source terminal of the gate drain source. Here also same, drain, gate. This is your source, right? Gate drain source. See, arrow. The position of arrow indicate that it is the N channel or P channel. See, as like a NPN and PNP transistor. Arrow towards the under, it indicate that N channel, N channel, N channel, APT indicate that field effect transistor. N channel APT, and here P channel, out of indicate P channel APT, APT indicate that field effect transistor. Just to tell you, see, why I'm telling you the thing related to the BJT and APT. See the diagram. This is the symbolic diagram of the NPN and PNP transistor. Basically, it is a transistor. Field effect transistor, it is also the transistor, but see, whatever the symbol with respect to field effect transistor, that are the different, right? See, this is the diagram. Gate means it have terminal. In case of your transistor, there is a collector base emitter, that are the 3 terminal. In case of gate, there is a gate, drain, source. These are the 3 terminal. Normally, the difference between this is that this is a current control, this is the voltage control. How it is, I'm telling you in a further session. Only thing is that we have to discuss the symbol of this. Now see, symbolic change with respect to this is that it have 3 things, means name, base, emitter, collector, and here gate, drain, source. These are the terminal with respect to field effect transistor, right? So what it indicate that it is a current control, it is a voltage control, that we have to be seen. Only here you have to see the symbol of the BJT and the field effect transistor. Okay, symbol एकदा नीट पाहून घ्या. आपण डिटेल पाहणार आहोत पुढे पीपीटी मध्ये. याच्यावर काही क्वेश्चन आहेत, मग तुम्हाला तुम्ही विचारणारच आहे की तुम्हाला काय याच्या रिस्पेक्ट टू काय क्वेश्चन दोन्ही मधला डिफरन्स लक्षात येतोय का? काय डिफरन्स आहे बरं सांगा बरं डायग्राम मध्ये पाहून. पहिला डिफरन्स सांगा. हा, गोरे, विनायक गोरे, काय डिफरन्स आहे ट्रान्झिस्टर आणि फील्ड इफेक्ट ट्रान्झिस्टर मध्ये दिसण्यासारखा डिफरन्स?
यस सर.
डिफरन्स काय आहे याच्यामध्ये डायग्राम मध्ये दिसण्यासारखा डिफरन्स?
याच्यात फील्ड इफेक्ट ट्रान्झिस्टर मध्ये गेट आहे, इकडे बेस आहे.
राइट, म्हणजे टर्मिनल नेम. इन केस ऑफ युअर BJT there is a emitter base collector, here is a gate drain source. That is the first
नेम चेंज आहे.
right, that is the first difference. Other changes, here is a bipolar junction transistor, here is a field effect transistor. That are the basic thing. Now we have to be seen the PPT of it, but to introduce the diagram means their diagram indicate that whatever the things means how it should be represented. That's why I'm draw this diagram. Now see the PPT. See, field effect transistor. See, we have just discussed the thing related to the junction field effect transistor, right? So why its name is field effect transistor? The reason behind it is we are applying the voltage with respect to this type of the transistor. We know that there are basically it is a transistor. There are 3 terminals with respect to this type of the transistor, that is gate, drain, and source, right? So we know that it is a voltage control devices. So that's to control the output current. We know that This type of the transistor, there is a 3-terminal gate, drain and source. Your output is coming across your drain, right? So we have applying the gate to source voltage which control the drain current, right? So electric field indicate that we have applying the electric field. It is nothing but a voltage in between your gate and source, that is VGS, which control the drain current, right? So this indicate that we have applying the electric field which controls the conductivity. Conductivity indicate that output current, right? This is the thing with respect to the field effect transistors. Means we have applying the voltage in between your gate to source which controls the drain current. So drain current indicate that it is nothing but a conductivity of the particular devices, right? See here, actual thing is written here. In case of field effect transistor, normally it is any electronic devices which should does the function of the to control the output current, right? So what do you mean by field effect transistor? So field effect transistor is nothing but it is the device. See, it is the devices which control the whatever the output current by applying input voltage. Input voltage indicate it is nothing but a electric field, right? So applied input electric field which control the output current. This is the thing happen with respect to your field effect transistor, right? So see, when we have to be control the output current by applying the input current, that is somewhat complex thing in case of your BJT, right? So to avoid that thing, we have to be done the other type of the construction with respect to your transistor, that is field effect transistor. In a field effect transistor, what we have to do, we have to be applied the voltage that is in between the gate to source. It is called as also electric field. So we are applying the electric field which control the output thing. Output thing indicate that output current. So in case of field effect transistor, we have applying the electric field which control the output current. Electric field indicate that it is nothing but a voltage. We are applying the voltage which control the output current. This will happen in case of your field effect transistor. The question asked in exam, your last exam, define the how the APT is defined, right? How the APT is defined, they have given the many more option, right? So the proper answer for it is that applied electric field which control the output current, or applied electric field which control the conductivity. That is the proper answer of the particular question. MCQ question asked in your exam. Okay, this type of the question asked in case of your exam, right? So field effect transistor have 3 terminal. We know that there are 3 terminal. One is your gate, other is drain, and the third is source, right? So gate, drain, source are the terminal in case of your APT, but in case of your transistor, there are emitter base collector, that are the 3 terminal, which is same as like as gate, drain, source, that are the terminal with respect to field effect transistor, right? So we know that I already told you field effect transistor indicate that applied input voltage which control the output current. So here it should be applied means where is the particular electric field or particular voltage applied. See, gate, source and drain, these are the 3 terminal with respect to your devices, right? So in between gate and source we have applying the voltage, that is nothing but a voltage applied between gate to source, that is called as VGS. VGS indicate that voltage between gate to source, right? So this is applied with respect to your APT which control the output current, right? So in case of APT, we have applying the voltage in between your gate to source which controls the drain current. This will be the thing happen with respect to APT. These are the some of the introductory thing with respect to APT. You have to only understand what do you mean by APT. APT indicate that it is the device in case of we have applying the input electric field which control the output conductivity or output current, right? This is only the thing with respect to this slide. लक्षात येत आहे का इलेक्ट्रिक म्हणजे एपीटी म्हणजे नेमकं काय केलं जातं? प्लीज रिप्लाय द्या. एपीटी मध्ये काय करतो आपण? ओके, we have applied the input field voltage which control the output current or output conductivity. This will be the thing only happen with respect to field effect transistor. That is the major difference between your field effect transistor and the normal transistor. In case of your normal transistor, we have applying the base current, right? See, we have applying the base current, that is input current, which control the output current, that is collector current. But in case of APT, we have applying the voltage that is in between your gate to source which control the drain current. That is the basic difference between your APT and the FET and the BJT. Okay. See, we have seen the some of the differences with respect to FET and BJT. In case of earlier exam, means when your written exam is happening, in that case, 4-mark question is asked in this point. You also some question on this differences also in your MCQ exam question, right? See, BJT indicate that bipolar junction transistor. FET indicate that field effect transistor. So in case of BJT, there should be current conduction happen due to the application of the input current, that is base current, which causes output current, that is collector current, should be generated. In case of FET, we have applied voltage which control the output current. That is different thing other than that of your BJT. See, FET we have to be apply the voltage in between your gate to source, which control the drain current. That will be happen in case of your FET. But other thing have BJT, that is the difference, right? See, first thing we have seen, long form of it. BJT indicate that bipolar junction transistor, FET indicate that field effect transistor. See, junction, in case of BJT there are two junction, which are that P and PN, that are the two junction. See, the basic difference between BJT and FET is that FET have only one junction, means in case of BJT we have seen the NPN, there are two junctions, N to P, P to N, right? But FET have only either N to P or P to N, means that are only one, means two condition, that is either your PN or NP, that are only thing with respect to the FET. But in case of BJT, NPN or the PNP, that are the two cases, and it have two junction, that is P to N, N to P. Here is only one junction, that will be happen in case of FET. Okay, its operation depend on the both majority charge carrier and minority charge carrier. See, its name indicate that BJT indicate that bipolar junction transistor. Bipolar indicate that there should be current conduction takes place due to the both, that is either your electron as well as holes. Means in case of BJT there should be current conduction takes place due to the both, that is electron as well as holes. That's why it is called as bipolar junction transistor. The basic difference between FET and BJT is that FET is a only the majority charge carrier. Majority charge carrier indicate that if see, consider the example of the PNP type of the transistor. See, PNP, here is a 2P and 1N. लक्षात येते का? PNP मध्ये 2P आणि 1N आहे. लक्षात येते तुमच्या? तर त्याच्यामध्ये मेजॉरिटी काय असेल रे? P मध्ये होल्स जास्त असतात, N मध्ये इलेक्ट्रॉन्स असतात. इथं 2P आणि 1N आहेत. तर मेजॉरिटी कोणाची असेल? Holes, right. So in case of PNP there is a in case of PNP there is a major is 2P. In case of NPN there is a majority of 2N. So that is the thing with respect to NPN or PNP type of the transistor. But in case of FET, here is only one thing is important, majority charge carrier, indicate that either your holes or electron, right? So in case of BJT there should be current conduction takes place due to the both electron as well as holes. But in case of FET there should be current conduction takes place only due to the either your holes or electron. Means there should not be current conduction takes place due to the both, that is electron as well as hole. But here either your holes measure or the electrons measure. According to that should be only used for the purpose of current conduction. That is the difference between FET and BJT. Then input impedance of BJT is very less. What it indicate that input impedance? See, actually gradual things, means the device which is more preferred. One of the important thing is that when the device which have more input impedance and less output impedance, that is the device which should be more preferred. Why? I'm telling you reason. See, when the device which have less input impedance, it is nothing but a resistor. It indicates that any of the noise signal should be attached with it. And if it have less output impedance, what it indicate that less output impedance indicate that any of the devices should be connected to other part. आता सांगतो, आपण जर एखादी स्टँडर्ड डिव्हाइस आहे, स्टँडर्ड डिव्हाइस म्हणजे काय असतं, त्याला जास्त हाय इनपुट इम्पिडन्स पाहिजे आणि लो आउटपुट इम्पिडन्स पाहिजे. लक्षात घ्या. तर ह्याचा फायदा काय सांगतो, जर तुमच्या डिव्हाइसचा हाय इनपुट इम्पिडन्स असेल तर त्याला काय होणार आहे, कुठलीही नॉईज त्याला अडवणार नाही. लो इनपुट इम्पिडन्स असल्यामुळे काय होईल, ते कशाशी कनेक्ट होईल. हे स्टँडर्डायझेशन आहेत. पण बीजेटी साठी कसं आहे, इनपुट इम्पिडन्स त्याचा जो आहे तो कमी आहे, म्हणजे स्टँडर्डायझेशन आहे. बट एपीटी साठी कसं आहे, इट हॅव द हाय इनपुट इम्पिडन्स आणि लो आउटपुट इम्पिडन्स. दॅट इज द प्रेफरेबल थिंग विथ रिस्पेक्ट टू द बीजेटी. बीजेटी पेक्षा एपीटी प्रिफर करायचं, कारण की हाय इनपुट इम्पिडन्स आहे, त्यामुळे नॉईज जास्त अडवत नाही. लो आउटपुट इम्पिडन्स आहे, म्हणजे त्यामुळे काय, तर कुठल्याही डिव्हाइसला ते कनेक्ट करू शकतात, लक्षात घ्या. ओके. देन fourth, it is the current control devices. So we know that BJT means applied base current, which controls the drain current. In case of APT, it is the voltage control devices, applied gate to source voltage, which control the drain current. This will be happen in case of APT. Okay, so that's why it is called as voltage control devices. Normally, low input impedance with respect to BJT. So low input indicated noise is added with it, so it is noisier. And APT, it is not noisier because it have high input impedance, so no noise is added with it. Then its frequency variation affect their performance. Frequency variation indicate that, see, when we have to be think with respect to BJT and APT for the different application. So when we have to be use it for the different application, in that case what we have to do, whatever the device used, they have operating different frequency. म्हणजे काय सांगतो, काही डिव्हाइस जर ऑपरेट होताना त्याची फ्रिक्वेन्सी समजा 10 हर्ट्ज ते 1 किलो हर्ट्ज पर्यंत वर्क होत असेल समजा, तर एवढ्या सगळ्या फ्रिक्वेन्सी वर्क करायचं असेल तर तेवढ्या फ्रिक्वेन्सीवर जर तुम्ही ट्रान्झिस्टर यूज केला ना, त्याचा परफॉर्मन्स ॲज इट इज, म्हणजे कमी फ्रिक्वेन्सीला जेवढा आहे तसंच जास्त फ्रिक्वेन्सीला राहील याची शक्यता नाही. पण जर आपण एपीटी जर तिथे यूज केलं ना, whole over means starter with 10 hertz frequency to the 10 kilohertz frequency, whatever the performance of the APT, that should not be changed, that will be happen. It is nothing but a high frequency response. BZ, it is a temperature dependent device. It is better temperature or heat stability, right? What it indicate that, it indicates that basically BJT, if the temperature changes with respect to your nature, so performance of your transistor that also changes, right? Means change in temperature that will be happen, in that case performance of your BJT that also changes. But APT, it have more stability with respect to the heat. It indicates that temperature, right? This will be happen. Okay. Normally BJT is less costly, means cost of the BJT normally 1-2 रुपये किंमत असते BJT ची, पण APT ची 90 रुपये APT आहे, लक्षात घ्या. Cost of APT is more. Okay. It is bigger on size than APT. So size of the, see, तुम्हाला IC टेक्नॉलॉजी नाव ऐकलं, इंटिग्रेटेड सर्किट, IC पाहिलेत का?
Yes, sir.
ओके. आयसी जर आपल्याला बनवायचे असतील ना, ऍक्च्युली एखादं कुठलं तर फंक्शन कार्य, म्हणजे जर एखादं तुम्ही पाहिलं असेल की आता डोअर बेल वगैरे असे काय काय नॉर्मलाइज एवढं स्मॉल साईजचे किट असतात, त्याच्यावर सगळं म्हणजे डोअर बेल वगैरे, त्याला जर एकीकडनं इनपुट दिलं, म्हणजे लॅम्पचं इनपुट दिलं, पॉवर दिली, तर इकडल्या साईडनं जर नुसतं आउटपुट कनेक्ट केलं तर तिथून तुम्हाला डोअर बेलचा वगैरे आवाज येतो, लक्षात घ्या. तर एवढं मोठे स्मॉलेस्ट सर्किट असतं, खूप लहान असतं, लक्षात घ्या. तर त्यामध्ये काय केलं असतं, ते एक आयसी, जे त्या आयसी मध्ये सगळे फंक्शन ऍड केले जातात आणि ते यूज केलं जातं. म्हणजे तिथं काय केलं जातं, त्या आयसी मध्ये जे नंबर ऑफ ट्रान्झिस्टर आहेत ना, ते त्याच्यामध्ये ऍड केले जातात. म्हणजे जर नंबर ऑफ ट्रान्झिस्टर तुमच्या आयसी मध्ये बनवायचे असतील ना, जर त्याची साईज स्मॉल असेल पहा, तर ते जास्तीत जास्त त्याच्या करता येतील आयसी मध्ये. पण बीजेटीची साईज जी आहे ना, खूप मोठी आहे, त्यामुळे ते कमी तुमच्या ट्रान्झिस्टरच्या पॅकेजिंगसाठी, म्हणजे ट्रान्झिस्टरमध्ये एखादं फंक्शन आपल्याला तयार करायचं असेल तर त्यासाठी बीजेटी तिथं जास्त लागतील, म्हणजेच त्याची साईज जास्त आहे, लक्षात घ्या. पण एपीटी तिथं कमी लागणार, कारण का की त्याची साईज कमी आहे. म्हणजेच साईज कमी किंवा जास्त हा आयसी टेक्नॉलॉजी, म्हणजे त्याची आयसी तयार करण्यासाठी लागणारा एक महत्वाचा मुद्दा होतो. साईज लक्षात घ्या, कधी पण कमी, म्हणजे एका ट्रान्झिस्टरची साईज समजा एका आयसीवर 100 बसतात, बीजेटी समजा 100 बसते आणि एपीटी 200 बसत असतील, तर कोणतं प्रेफर कराल तुम्ही? आयसी मध्ये काय असतं, आयसी टेक्नॉलॉजी जास्तीत जास्त बसायला पाहिजेत, बीजेटी असो एपीटी असो. लक्षात घ्या, एक आयसी तयार केला ज्याच्यात बीजेटी 100 बसतात आणि त्याच सगळ्या कॉन्फिगरेशनचे एपीटी मात्र 200 बसतात. काय प्रेफर कराल तुम्ही?
APT.
Okay, APT. Why? Because APT are more than that of BJT and it should implement more function. That is the thing with respect to APT. Okay, and it has an offset voltage. It has no offset voltage. Offset voltage means what? There is offset indicate that if we have not applying any input, also we got the sum of the output. This is nothing but output. In case of BJT, म्हणजे जर आपण काय जर इनपुट नसलं अप्लाय केलं ना तरी सुद्धा काय आउटपुट मिळतं ते तुमच्या एपीटी बीजेटी मध्ये होत असतं. पण एपीटी मध्ये तसं होत नाही कारण का त्याला हाय इनपुट इम्पेडन्स असतो इनपुटला, त्यामुळे तिथं नॉइज ऍड व्हायचीच प्रश्न नाही, त्यामुळे आउटपुटला काहीच येणार नाही. ओके, दिस विल बी हॅपन इन केस ऑफ एपीटी. देन it has an more gain, it has less gain. Gain indicate that it is the ratio of the output to the input, right? So BJT have output to input ratio that is a more means more म्हणजे जर तुम्ही स्मॉलेस्ट इनपुट जर अप्लाय केलं ना तर लार्जेस्ट आउटपुट तुमच्या बीजेटी साठी येतं. एपीटी साठी जर तुम्ही जास्त इनपुट अप्लाय केलं ना तरी सुद्धा त्या प्रमाणात त्याचं इनपुट अँप्लिफाय होत नाही. लक्षात घ्या, एपीटी तरी सुद्धा. आता मला तुम्ही सांगा, आता पॉझिटिव्ह थिंग कोणाचे जास्त आहेत? आता मी सांगितलेल्या पॉईंटच्या रिस्पेक्ट टू बीजेटी आणि एपीटीच्या रिस्पेक्ट टू. लक्षात घ्या, बीजेटी आणि एपीटी नॉर्मली अँप्लिफायर ऍप्लिकेशन साठी यूज केले जातात. अँप्लिफायरला काय असते, इनपुट म्हणजे जे अप्लाय केलं ना त्यापेक्षा जास्त मिळायला पाहिजे. तर तुम्ही बीजेटी प्रिफर कराल की एपीटी? नॉर्मलाइज सांगा मला, काय म्हणायचे प्रत्येक सांगा मला काय म्हणायचंय. ज्यावेळेस अँप्लिफायर ऍप्लिकेशन असेल ना, इनपुट अप्लाय केलं ना त्यापेक्षा जास्तीत जास्त आउटपुट अँप्लिफाईड मिळायला पाहिजे. तर बीजेटीला जर दिलं ना तर जास्त मिळतं, एपीटीला दिलं तर कमी मिळतं. कोणतं प्रिफर कराल? बीजेटी. तरी पण सांगतो बीजेटी प्रिफर केला जात नाही, त्याचं रिझन सांगतो. तुम्ही तुमचं, मी जे गोष्टी सांगितल्या त्याप्रमाणे तुमचा आन्सर बरोबर आहे, पण इन केस ऑफ युअर actual thing there is not right. Why it is? Because in case of BJT there should be so many problems coming with respect to BJT. They have less input impedance, they have noise is more, they have all other problem coming with respect to BJT. But in case of APT, if it have less gain, that is acceptable. Why it is? Because only thing is less gain, but all other thing, input impedance, noise, that should be less in case of APT. That's why in the application of your amplifier we have to be prefer the APT. And one of the major thing in case of APT, it is a voltage control devices, means applied input voltage which control the output current, right? That's why in amplifier application we have to be more and more prefer APT. Okay, okay, there is a meeting, so that's why we have to be stop here now. Okay, give me the attendance. Roll number 1. Roll number 1. माझा आवाज ऐकू येतोय? रोल नंबर 1.
Yes.
2.
Present, sir.
3. 4.
Present, sir.
5. 6.
Yes, sir.
7. 8. 9. 10. 11.
Present, sir.
12. 14, 15,
Present, sir. 10 present.
16, 17, 18,
Present, sir. 14 present.
present, sir.
19.
18 present, sir.
Okay,
18.
19. Oh, 19, 20, 21, 22,
Present, sir. 21.
21. Okay, 23, 24, 25, 26, 27, 28, 29, 30.
Yes, sir.
31,
29.
29. Okay.
Sir,
30,
yes, sir.
31, 32, 33,
Present, sir.
34, 35,
Present, sir.
36, 37, 38.
Yes, sir.
Option number सांगतो.
Yes, sir.
Option number 1, 4, 7, 8, 9, 10, 12, 13, 14, 17, 19, 20, 23, 24, 25, 26, 27, 28, 32, 34,
20 present, sir.
So 12 present है.
20 present.
20, 12. हाँ, okay. 20, 12.
Present.
14 present, sir.
एका
14.
14 present.
Sir, 10 present आहे.
10 present. Okay.
23.
23. Okay.
23, sir.
Oh, 4,
8, sir.
23 आज झालं.
33.
33 प्रेझेंटच आहे. ओके ओके स्टॉप करू.